Okay, this question involves a problem that has a Ferris wheel. Now, a Ferris wheel is a kind of a amusement park type of a device that rotates round and round, and you have people sitting in it here and here. And I'll just kind of draw a person like that, and you can put a person here. But essentially, people are sitting, or in this case, I've drawn them as standing in the Ferris wheel. So this is called a Ferris wheel. And the question is saying, if it has a diameter of 22.5 meters, in other words, from here to here is 22.5 meters, and it rotates once, so the period is equal to 12.5 seconds. If that's the period, what is the fractional change in the person's apparent weight at the top and at the bottom? So what we're going to remember is that the normal force is the apparent weight. And so now what we need to do is find Fn at the top and at the bottom. So let's take a look at the bottom first. Let's go bottom first. At the bottom, we've got gravity going down, and we've got normal force going up. We do summation of the forces centripetal is equal to F net centripetal. So that means, remember, the center of rotation is right here. So that means the center of rotation is above here. That means Fn is positive and mg is negative, because mg is pointing away from the center of rotation. And then that's going to give us MAC. And that's going to give us mv squared over r. However, they haven't given us v, they've given us t here. But we can convert that. We can say v equals 2 pi r over t. And so we can substitute that in for v. Now, let's go ahead and solve for Fn. Fn is going to be mg plus, so because take this whole term, it's a negative on this side, becomes positive on the other side, plus mv squared over r. And I can factor out the m. And so I will get g plus v squared over r. And now I can substitute in this for v. So I'm going to get uh, 2 pi r over t, and square all that and divide that by r. And so what is that going to give me? Well, if I work it out, I'm going to get mg plus 4 pi squared r squared over t squared, and divided by r. Now this r cancels that square, and so I end up with simply 4 pi squared r over t squared. So if I recognize how much more that is, that's actually this much more than the regular mg. So this box here is my, you could say, increase compared to 9.8, because g is 9.8. So however much this is, where r is simply my diameter divided by 2. And that's that problem. Thanks for watching.